Okay, we're reviewing naming and formulas in grade 10, which I hope you learned in grade 9, but we're going to do it again. There's two types of compounds. Khalil, give me one.
Ionic.
Ionic. And Bianca, give me another one.
Covalent.
Covalent. So it's ionic or covalent. Does anybody know how you tell ionic from covalent? What does an ionic compound have that covalent does not?
Metal.
A metal. Thank you, Nathan. Let's give him a golf clap. We're going to go over ionic compounds, naming and formulas today. And next day we'll go through covalent. So if it has a metal, it's ionic. So if I give you this formula, you know it's ionic because aluminum is a metal, right? If you want to name it, you just write the metal as the metal. You just write it normally. The non-metal, if it's a regular element, you take its regular name and you change the ending to IDE, ide. So this would become oxide. So you just say aluminum oxide, that's the name. How do you know if it's just a regular element or if it's a polyatomic ion? Good. Thank you, Damien. If it has just one capital letter, what is it? Is it regular element or polyatomic? No? Good. Regular. Turn to the person beside you, tell them if it has one capital letter, it's a regular element. Okay, so then what if it has more than one? Bianca? Lucas, if it has more than one capital letter, good. Thank you very much. Regular elements are on your periodic table. Shrish, where are the polyatomic ions?
On the back.
On the back. Here's a list. These are all the ones you need to know in grade 10. There are more, but we don't care about them. So here's a list of how you do this. If I give you the formulas and you have to name them, you go through and you go, okay, here's a metal. Metal's just a metal. We don't care about these numbers in ionic compounds. Let me say that again really clearly. Nathan. Nathan, look at me. What is he doing? Oh. I can't see you because your glasses are...
I was looking at you.
That's fair. I'm gonna do the same. If you ever want to like really patronize someone, you get glasses, and then you like, if they do something, you're like, like that. I'm not very good at it, but I had some teachers that were in my day. Anyway, ionic compounds, if they only have two capital letters like this one does, they're both regular elements. And you just write the names of the elements. We don't worry about the numbers in an ionic formula. So there's no ditri, tetra. That's all covalent compounds, which we'll learn next day. So we don't need the prefixes in ionic compounds. We do not need those. So we just say sodium oxide, and that's it. It's sodium and it's oxygen, so it's sodium oxide. Boom, done. If you don't know how to change the oxygen and you go oxygenide or oxygide or whatever, that's fine with me. I'm not worried about that. You'll get familiar with this later. This is calcium and sulfur, so it's calcium sulfide. This is lithium and selenium, so it's lithium selenide. That's it. This one has three capital letters, so it has to have a polyatomic. So you go, K is potassium, and then CrO4, you look on the back, is chromate. So this is potassium chromate. So you just write the name that's written right on here. And this is magnesium, and NO3 is nitrate. Now on here it's just going to say NO3. It doesn't have the brackets with the 2. But that's okay because this NO3, there's 2 of them in this compound, but the NO3 is the polyatomic. So that's what you write. That's just the name of that polyatomic. This is magnesium nitrate. OH is an exception. It's a polyatomic, but it ends in IDE. OH is very common. All bases have hydroxide in them. So this is beryllium hydroxide. That's it. Okay, if I give you the names and you have to write formulas, it's a little more complicated because we got to do some numbers and a little bit of simple math. But it's not too bad. So magnesium dichromate, if it doesn't end in IDE, if it's cyanide, it's polyatomic, or if it's hydroxide, it's polyatomic. But those are the only 2 exceptions. So if it ends in IDE, it's a regular element. If it does not end in IDE, it has to be a polyatomic, so it's on the back. So you go magnesium is Mg, and then dichromate does not end in IDE, so you look on the back, and you go dichromate is Cr2O7. There's no extra numbers here because magnesium is +2 and dichromate is -2. So the magnesium gives 2 to 1 dichromate, and you only need 1 of each, and you don't need any extra numbers. Iron 2 nitrate is weird because it has this. This Roman numeral tells you the charge that the iron is using. So if you look on the periodic table, iron can be +3 or +2. And so that 2 tells you that iron is using +2. So you just write the symbol for iron. And then this is not IDE. So you look on the back on your list of polyatomic ions. And nitrate is NO3, so you put the NO3 there. But this time you need more than 1 nitrate. So I said that Leo and Dennis were both nitrates. They both needed 1 because the charge is -1. But this iron is a +2, so I was the iron and I had to give 1 to each of them. So to make a compound, you only need 1 iron, but you need 2 nitrates. But you do not change the number in the polyatomic. The polyatomic ion always stays the same. You just put brackets around it if it's more than 1, and you write how many there are outside the brackets. So we had 1 iron, 2 nitrates, so you put the brackets and you do the 2, and you're good. And then sodium chloride is really simple because sodium is +1 and chloride is just chlorine and it's -1. So that's like a regular on the periodic table element. And that's the end. So that's ionic bonding with a metal and a non-metal. And that's how you write the names and do the formulas. And I'll post these, and Bianca's going to remind me in a second to do the other videos too.